So in this lesson, we're going to be reviewing compound inequalities. 3 things we're going to learn: writing and graphing compound inequalities, solving compound inequalities, and we can use compound inequalities to solve real-life problems. Let's get this definition down first. A compound inequality is an inequality formed by joining 2 inequalities with the word and or the word or. So when you have inequalities and you have two options, right? One is less than, and the second one is greater than. All right. Compound inequalities, to get for a hint for it being less than, okay, being an and statement, right? We said there's 2 different ways: an and statement and an or statement. When you see the less than sign, right? If you notice the last word here, less than, if you kind of throw a d at the end of here, it's an and statement. Right? So if it's an inequality with a less than sign, less than is an and statement. If you see an inequality with a greater sign, I misspelled this purposely because why? Greater is an or statement. All right, so just a little something to help you remember which one's and which one's or. Let's take a look at the number line, so you can see the difference on a number line of an and statement and an or statement. So these are all examples of and statements. If you notice, okay, if I write 2 separate inequalities here, I'm going to say x is greater than or equal to -6, and x is less than 3. Open circle, closed circle, greater than or equal to, open circle, less than 3. Next one. Another option is x is greater than, open circle, -5, and x is less than or equal to, being a closed circle, to 4. How about C? Anybody think they could do C?
X is greater than 5.
For this one, x, it's -4. X is greater than or equal to,
-4.
and
And x is greater than or less than or equal to 5.
less than or equal to 5. Perfect. What about the next one?
X is greater than -3.
Greater than -3, and
X is less than 6.
less than 6. Perfect. Okay, let's take a look at the or statements. So if you notice the little difference here, now they're going in 2 different directions, your or statements. So your first one, x is, closed circle, less than or equal to -6, or x is greater than 3. So your solutions are anywhere from -6 and down, and greater than -3 and up. So you're leaving out the middle here for the or statements. How about B? Volunteer for B?
X is less than -5.
X is less than -5, or
X is greater than or equal to 4.
perfect. X is greater than or equal to 4. How about the next one?
X is less than or equal to -4.
Less than or equal to -4, or
Or X is greater than or less than or greater than or equal to 5.
perfect. X is greater than or equal to 5. And my last one here,
X is less than or equal to -4.
X is less than
Less than -3.
or
Or equal to
X is
X is greater.
greater than 6. Perfect. So solve the inequality, graph the solution. -4 is less than x minus 2, which is less than 3. Okay, so I want to solve this for x, so I want to get rid of this -2 here. Okay, so I'm going to add 2, but now I have 2 different sides. Okay, so I'm going to add 2 here to get rid of my 2, but I need to add 2 to this side, and I need to add 2 also to this side. So I'm going to do it simultaneously. Rather than splitting up the inequality, I'm going to do it all together. Bring this out, so -4 plus 2, I get -2 is less than x, which is less than 5. When you have this solution, this should always be your minimum value, this should always be your maximum value. So on a number line, I got -2, I got 5, My inequalities do not have the equal sign, so these are both open circles. If you read this one backwards, this is saying x is greater than negative 2, so that's going this way. If you read this one, x is less than 5, that's going that way. So my solution for this will be everything in between negative 2 and negative 5. Alright, next example, solve the inequality and graph the solution. So negative 3 is less than negative 2x plus 1, which is less than or equal to 9. What's my first step here? I'm solving for x. What's my first step?
Subtract the
Yeah, I'm going to subtract 1 from both sides. So I got negative 4 is less than negative 2x. That goes away. Less than or equal to 9 minus 1, and I get 8. What's my next step now?
You isolate the x
How?
by dividing negative 2 on each side.
Beautiful. I'm going to divide by negative 2 on both sides. And what's my next question I'm going to ask you guys?
When you divide by a negative number, you switch the sign.
Excellent. When dividing by a negative number, make sure you switch the sign. So how many signs do I have to switch now? 2 different signs, right? So negative 4 divided by negative 2 is positive 2. Switch that. This goes away. X dividing by a negative, switch. 8 divided by negative 2 is negative 4. Now here's something you just have to change. My minimum is not, and the max are not in the right order. So let's swap this. So let's make sure let's make sure my negative 4 is here and my 2 is here. Be careful with the inequality signs. This is saying x is greater than or equal to negative 4. So when you write this, make sure x is still greater than or equal to negative 4. X is less than 2. X is less than 2. Number line. 2 coordinates, negative 4, negative 2. Open circle, closed circle on negative 4. Has the equal sign, therefore it's going to be closed, so closed circle. Open circle on 2. This is saying x is greater than negative 4, going this way. X is less than 2, going that way. So my solution set is between negative 4 and negative 2. Alright, so here we have an example of an OR statement. Solve 3y minus 5 is less than negative 8, or, again, I'm telling you this is an OR statement, 2y minus 1 is greater than 5. So let's do my first one first. So 3y minus 5 is less than negative 8, and the second one is 2y minus 1 is greater than 5. So here if we solve for y, I'm going to bring my 5 over by adding it to both sides. So I get 3y is less than, if I add 5 to both sides, I get less than negative 3. Divide both sides by 3 here, and I get y is less than negative 1. On the second side here, I'm going to bring the 1 over, so I get 2y is greater than, adding 1 to both sides, 2y is greater than 6. Then dividing both sides by 2, and I get y is greater than 3. So here's my 2 statements. I'm going to draw my number line at negative 1 and at 3. Equality signs tells me I have an open circle on both. First statement says y is less than negative 1, so that's going to the left. Second statement says y is greater than 3, that goes to the right. So my solutions that will work for this equations is anything less than negative 1 and anything greater than 3. And this would be an example of an OR statement. So here's an example of some special case inequalities. 2x is less than x minus 1, and 10 is greater than or equal to 2 times the quantity of x plus 4. So if we solve this first one here, we have 2x is less than 1x minus 1. I'm going to subtract 1x from both sides, and I'll get x is less than negative 1. And if we do the other one here, we divide both sides by 2. So I have 5 is greater than or equal to x plus 4. Subtracting 4 from both sides, and I get 1 is greater than or equal to x, or vice versa. And if I throw this on my number line, question?
I distributed in the first step instead of dividing, and I got the same things.
Yep, you can distribute or you can divide by 2 in the first step, your choice.
Okay.
So here I have negative 1 and 1. I have an open circle here at negative 1. I have a closed circle here at 1. My first equality says x is less than negative 1, so everything going to the left. The second one says x is less than or equal to 1, if I read it correctly. That's also everything going to the left. So both these inequalities overlap. So you just stick with this first one here, and so your solution set is anything that's less than or equal to 1 will work. So here's a few examples to try. At this point I would pause this at this part here, try these examples, and then check your answers. Answers are as follows. Alright, so here's an application with compound inequalities. Electrical devices should operate efficiently within a specified temperature range. Outside the operating temperature range, the device may fail. So here I have an iPhone, and the operating temperature is between 0 degrees to 35 degrees Celsius. Write inside of a compound inequality that represents the possible operating temperatures in degrees Fahrenheit of the smartphone. So let's start that part first. So let's start with our given. So our temperature must be between 0 degrees and 35 degrees Celsius. So the Celsius must be less than 35 degrees and greater than 0 degrees. Now we want this in Fahrenheit. So how do I convert Celsius to Fahrenheit? What's my formula for Fahrenheit? So 0 is less than what?
9/5, and then C minus.
Okay, so give me the formula before you convert, before it's F equals. So C equals what? What's the formula for Celsius? C equals 5/9 times the quantity of
F minus 32.
F minus 32. Perfect. Less than 35. So the formula for Celsius is as follows. Now let's convert this. Let's get it so it's just F in the middle. What do I do first?
Divide by 5 9.
Divide by 5/9, or another way to look at it is
Times 9 over.
multiplying by its reciprocal, 9/5. And remember, I have to do it to all sides. Okay. So if I go from here, 9/5 times 0 is still 0. Less than. My 5/9 and 9/5 simplifies, and I'm left with F minus 32 less than 35 times 9/5, 63. One more step. I don't want F minus 32, I just want F. So what do I do now?
Add 32.
Yeah, I'm going to add 32 to both sides. Plus 32, plus 32, plus 32. So here I get 32 is less than F, which is less than 63 plus 32, 95. So the operating temperature must be between 32 degrees Fahrenheit and 95 degrees Fahrenheit.